When you're building an app or website, one of the hardest things is learning how to break down a project and push through the problems faced. There's almost a deer in the headlights feeling. Here's a weather app called Open Sky that I built, and I'm going to take you through my process from beginning to end of how I built this. We're going to display the weather data such as current conditions, the next 24 hours, and the next 7 days for your current location based upon your phone's GPS. We're not going to look at every single line of code, but the app's full source code is linked in the description on GitHub. So let's get started. Before I even get started, I used Canva to mock up what I want to build. Now, you don't have to use Canva, you can just draw it out on a piece of paper. But I think it's a good idea before you start with something like this to get an idea of where you're going to go to make it easier for you to get started and break it down into the steps to get there. There's a today screen with the current conditions, as well as the next 24-hour forecast, and a week screen with the forecast for the next week, as well as buttons between the two. Once I'm to this point, I take the overall idea and break it down into smaller pieces. There's a current weather snapshot, a 24-hour list, and a list for the next week's weather on the other screen. The first piece of the app I'm going to tackle is the 24-hour snapshot view. Before that though, I needed to go ahead and get a test app that can be deployed to my phone. I've decided to use React Native because it will make it easy to have an app that runs on both Android and iOS. This is also my first React Native app, which is perfect because I should encounter extra problems to troubleshoot along the way. React Native integrates with an app called Expo, which made some complicated steps super simple. I use Expo to create my project. I choose a simple app setup with TypeScript, and Expo generates some boilerplate code for us. Boilerplate code is basically the minimum amount of code required to get a project to work. New project generators like this are fairly common no matter what technology you are using. I then go into my projects directory and I can start my app using Expo. Developing React Native is really sweet with Expo because if I have the Expo app installed on my phone, I can scan the QR code and access the app on my iPhone or an Android device if that's what you have. I went ahead and set up Android Studio and created an Android virtual device to run an emulated Android phone on my PC. Expo was then able to deploy my app on the phone. The app would also live reload, which means changes would automatically populate when I save changes to a file. I found this to be my preferred way to work on the app, though if you are using live reload, that'll also work if you're running the app on your regular phone across Wi-Fi as well. Now that we can use the app we're building easily, we can go ahead and start working on the live weather snapshot. I started building the live view for today. Eventually, this would get real weather data, but to start with, I always focus on getting basic things working. Trying to go too far too soon when building an app can actually slow you down. Instead, break it down into pieces and figure out how to build in small increments, slowly adding complexity to the project as you go. As you can see, I ran into a bit of trouble here. I'm using something called Flexbox to position my elements on my page. Flexbox gives an easy way to position elements as a group, either horizontally or vertically. Most of the problems I pushed through pretty easily, but I definitely learned that I should work more with Flexbox after this. I did run into one problem with Flexbox that was hard to understand. The elements on the screen should stretch all the way from left to right. The outside element should stretch them. After struggling with this for about 30 minutes, I realized I needed to make it more apparent what was going on. I needed to know what the outside piece was doing. I made the background color red, and it made it apparent the problem was not the stuff inside, but rather the outside container that should be taking up the full width. This made it much easier to debug the problem than it had been. When having problems that aren't apparent, figuring out a way to visualize what's wrong like I did here is often going to be how I solve my problem. Making the circle around the text wasn't as straightforward as I thought. I kept thinking it wasn't a perfectly round circle. I thought for a second maybe I was just being OCD until eventually I increased the size of the circle to make it more apparent. It was then that I realized we definitely have a problem. I was thinking the border radius was percentages and 50% would create a circle around whatever was inside of it, since there was a corner to half the length of every side of the shape making a circle. Eventually I figured out it was just in absolute units and I needed a different approach. I settled on having absolute units that never change and setting the border radius to half of the width. This means the circle will always be exactly the same size. This isn't ideal. If the content ever got really large outside of the bounds of the circle, it would escape, but I felt it was good enough for government work. I continued on to finalize a few aspects of the snapshot view, and I finally was ready to move towards integrating real data. Next, I needed to pull weather data into the app. How did I do that? Our phone just doesn't magically know what the weather is. We need to get that data from somewhere. Apps and websites typically get the data like this from something called an API or Application Programming Interface. There's tons of weather APIs out there, but I decided to use Climacell. It seemed to offer the most access to data for its free tier, and I just wanted to point out that I'm cheap. In order to access data from Climacell, I had to sign up on their website. This gave me my access token, which allowed me to get data from the Climacell API. Think of this access token as my password to get data from Climacell. I placed this token in secret.ts since it's for my eyes and my eyes only. If you want to use the app's code, you'll need to get your own access token from Climacell and enter it into secret.ts. Climacell will allow us to get weather data such as current conditions. If you go to their website, you'll see that they have extensive documentation on the different data you can request. We'll be using what is called a GET request, which essentially uses a website URL to get data from a server. We tell Climacell what weather we want and our location, aka latitude and longitude. Then Climacell sends what we requested back. I love that Climacell's website lets you play around with it and gives you examples of what the request URIs and data coming back look like. From a software design perspective, I did not want the app directly dependent on Climacell, so I defined an interface that I could then implement to get data from the Climacell API. This works nicely because our app does not want Climacell data, it wants weather data. If we want to get our weather data from somewhere else, we could easily implement a new API class that implements the weather API and completely replace Climacell with no changes needed other than telling our app to consume the other API. I created a Climacell class that returns fake promises. This allowed me to tie in the front end of the application to the API class, and I could then replace this code with code to fetch data from the remote API layer. I ran into a problem where things started to break. I became immediately confused, so I added in a console.log and found that Climacell was telling me I had hit my rate limit, which means I was using it too much. I logged into Climacell confused because I had not been doing much, but holy shit, I had consumed over 100 requests in a few minutes. I couldn't use the API for an hour. I could pay to upgrade my Climacell account, but if I could describe myself in one word, I would easily say cheap. There I was, twiddling my thumbs. I began to wonder how I consumed so much data so quickly. I decided to see how often my API request was being called. I quickly figured out that I had a problem. My app was calling the API much more often than it should be. Whoops, I had left out a key piece in my app to tell it to only load data at a specific time. Instead, it was loading data over and over and over again. I quickly fixed this problem and finished off implementing the Climacell API. I was overall happy with the implementation, though in the future, I would not do the temperature rounding in the API class itself. That should have been handled by a different layer of logic. Before I moved on to the 24-hour view, I went ahead and created a different component and broke out the current snapshot. This makes the code I'm working on more maintainable because I don't have all this code laying in one file. I have the main app and then I have the current snapshot somewhere else. I proceeded with similar steps as before. First, I got the hourly weather displaying and then I worked towards tying in the API. This helped me break the problem down into different steps and solve them individually. For the hourly display, I wanted to display the time in a particular format like 11 a.m., 12 p.m., 1 p.m., etc. Originally, I tried using JavaScript to do this, but found it really tedious and ran into some issues. In case you're not aware, using dates and times in JavaScript, especially if you're trying to use like time zones and stuff, this is just like my personal rant, it's a total pain in the ass. But luckily, there's other JavaScript libraries like Moment.js. And luckily, because I'm using React Native, I was able to take that library and use it. So I took Moment.js and used it to help me display and format my date the way that I want it. So this made that entire process a lot easier. So after that, I wanted to work on getting menu buttons and the link between the week and daily pages working. React Native has a built-in way for handling screens that I like, so I used that. I worked towards getting buttons in place and added a placeholder week page to navigate back and forth. For the week page, I again did it in my steps as before. First, I got the view working, then I worked towards integrating the API. Working with buttons didn't come without surprises. I had some issues with getting them to position correctly when using the React Native buttons. No matter what I did, it seemed like the buttons would not position how I wanted. After a bit of searching around, I found some Stack Overflow posts hinting at these problems. I decided to try to use a different element. I found that touchable highlight seemed to be better for having control over the styles in mind. I suspect there was something weird going on with the React buttons, but I don't know, I'll come back to that later. When I was writing the original original code from the daily forecast, I wrote some really jacked up code meant to determine the description of what the weather is. For example, raining, cloudy, snowing, etc. This code was really crappy and involved me searching Google for info like what percentage of cloudy is considered partly cloudy, what's clear, etc. Spoiler alert, depending upon who you ask and who's telling you, the interpretation was different. But I went ahead and threw code together thinking this must be the only way, and confirmed my suspicions that, yes, weathermen are a lot like politicians. When I went to try to integrate the weekly forecast, one of the fields I had used in my calculation was missing. How was I going to use my groundbreaking formula if the API didn't have the cloud cover for the daily weather data? I began investigating and found that I had missed a field in the API docs called weather code that would take care of this for me. So remember, if something seems harder than it should be, it probably is, and investigate further. I lost a lot of time when I did not know about the weather code data point for mapping to a weather description. Once the weekly data was implemented, I refactored some of the files into folders such as the screens folder and a data folder. This was a light cleanup for sharing my code on GitHub. I hope you learned some debugging techniques and have a better idea of how to break projects down. I look forward to posting a code review of this app in the near future because I know that it's far from perfect. For that video and more content, be sure to like and subscribe.